Okay, so here we're ready to start doing some exercises, some actual problems where we're going to graph polynomials that are in factored form. Here we want to graph f of x equals -2 times x plus 3 times x plus 1 squared times x minus 2. And so we need to check the end behavior. And we also need to consider the multiplicity of the zeros and their effect on the graph. Those are going to be the two components we're going to use to analyze this. Now, maybe end behavior first of all. We need to decide what the degree of this polynomial is and what the lead coefficient. That's for the end behavior analysis. Now, when you see this polynomial f of x, I could write it out in this way. And I said a little bit about this in the previous video. You do need to be able to imagine what it means to multiply this out. Now, I could, I guess, start with these two factors and these two factors. Now, I don't really want you to multiply this out. That's x squared, I think I get minus x minus 2. But just what I want you to think about is how at each stage of multiplying it out, it's really like this x times this x times this x times this x will contribute to that leading term, that term of highest degree. In fact, at this point, I could take x squared times x squared is x to the fourth, plus 4x cubed plus 3x squared. I took x squared times each of those, and now minus x cubed minus 4x squared minus 3x, etc., etc., etc. I really don't want to go through all those steps. But when I take this x squared times this x squared, that gave me this x to the fourth. That's, I'm not going to get any other x to the fourth terms out of this multiplication. So when all this is done, I'll have minus 2x to the fourth plus other terms of lesser degree. And so the degree here is 4. And the lead coefficient is -2. Now, you want to be able to just not have to write so much down. You just want to realize that the x from each one of these linear factors, these factors, will contribute to that final degree. And then you have to count the x plus 1 here twice since it occurs to the second power, right? So we have x times x times x times x. That's where my x to the fourth comes from. From these, really there are 4 factors there. And then that will get multiplied by -2. So its leading term will be minus 2x to the fourth, kind of like I was saying here on this sheet. So since it's degree 4 and lead coefficient is -2, the end behavior is like y equals -x to the fourth. So we needed to determine whether that lead coefficient was positive or negative. The degree 4 tells us it's like an x to the fourth. Negative x to the fourth has a shape like so. So we know both ends are plunging down to minus infinity. Now let's look at the multiplicity of zeros. So I want to say something about the zeros too, because I'm afraid maybe I was jumping over that too quickly. Just holding a sheet of paper here. In that earlier video, to get the x-intercepts of the zeros, you set the function expression equal to 0. So we get this whole thing equal to 0, and because we have it already in factored form, we can take this apart by the 0 property. And just in case that x plus 1 squared bothers anyone, I just want you to see that that x plus 1 squared is just a factor of x plus 1 times itself, right? So when we separate this by the 0 property, we get, well, one factor is -2. -2 can't equal 0. That gives us no solution. The next factor, x plus 3, would be equal to 0. Then x plus 1 equal to 0. X plus 1 equals 0. X minus 2 equals 0. We get x equals -3 here. X equals -1 here. Same thing from that factor, of course. X equals 2. So the zeros are going to be -3, -1, and 2. Okay. This -2 factor out front doesn't contribute to the zeros at all. That there are no x-intercepts that corresponds to. There's no variable there that we can solve for. So we have 3 zeros. So we have x equals -3 and x equals 2 of multiplicity 1, and we have x equals -1 of multiplicity 2, because that factor occurs to the second power. And now let's start working on a graph here. So this is a rough sketch kind of graph, and maybe I'll go 1, 2, 3, -1, -2, -3, and let's see, we got a 0 at -3, a 0 at 2, and at x equals -1, we got a 0 of multiplicity 2. Now, I don't know right now if the graph, like, which way the graph cuts through these zeros. And I don't want to pick values close to each 0 like I did in that previous discussion. That was just to help motivate this idea. What I'm going to do, though, is I'm going to work from the end behavior that has to be similar, has to match up with the end behavior for y equals -x to the 4th. So at each end of my graph, I know I'm plunging downward, right? So the graph has to come up, actually if I start from the negative end, I'm coming up from -infinity. I'm hitting that 0 at -3. It's of multiplicity 1, so I cross the x-axis. Then somewhere I got to turn around and come back to this next 0 at -1. Because it's of multiplicity 2, I need to just turn around, right? I can't cross the x-axis there. I just bounce off. Now I have to get back to this next 0 at 2, and there I do cross the axis because it's a 0 of multiplicity 1, and then I just continue down in a negative direction. So that's it. There's my rough sketch of the function in exercise 1, and that's really all we're after. We could plug in points, we could analyze, and we could look at a y-intercept more carefully, but for this portion, that's really all we want. Okay. And I think I'll do another exercise in a separate video. I want this f of x equals -2 times x plus 3 times x plus 1 squared times x minus 2. There's our graph.